Hi everybody, we're going to talk about acid-base equilibrium today. Now in grade 9, 10, and 11 you basically learn about Arrhenius acids and bases, and we basically said to you that acids begin with a hydrogen and bases end with a hydroxide, and when we mix them together we get a water and a salt, an ionic compound of some type. In grade 12 we have a little bit more of a nuanced look at acids and bases. We use something called the Bronsted-Lowry theory. And in that theory, acids donate a hydrogen ion. A hydrogen ion is the same as a proton. Well, why is that? Well, if we have a hydrogen ion, it has both a proton and an electron. It's the only element that doesn't have a neutron. So when you lose that electron and it becomes an ion, all you're left with is a proton. So, chemists a lot of the time will just say proton instead of hydrogen ion. I'll use them back and forth. So while acids donate a proton, bases will accept a proton. And so if we look here at this structure, I have an acid, I have a base. Here, the acid is going to donate the proton to the base. Then that means what's left over, the chlorine ion, becomes the base. And this new thing we haven't seen before, this thing we call hydronium ion, becomes the new acid. And if we reverse, it'll go this way. Now, next class, we're going to learn that this is actually a strong acid, so it won't reverse. But for now, we'll just imagine that it can. Same thing here with ammonia. Ammonia here is going to steal a hydrogen ion or a proton from this water, which is going to be acting like the acid. It's going to be the proton donator. The NH3 is going to be the proton acceptor. And therefore, we're going to get ammonium ion and hydroxide. You can always tell if it's an acid reaction because you'll get this hydronium ion, and it's a base reaction when you get this hydroxide being formed. Now, each pair of acids and bases will only differ by one hydrogen, and when they're like that, they're said to be conjugate pairs. So, for example, ammonia and ammonium, they only differ by one. The one with the least or the less amount of hydrogens, that's going to be your base. And the one with more amount of hydrogens is going to be your acid. Hydrochloric acid, chlorine ion, acid versus base. Water in this case is going to be the base because it's going to accept the proton from the acid. Here water is going to be the acid because hydroxide would accept that proton. Now a lot of times, not a lot of times, but sometimes water specifically can be an acid or a base, and we've seen that in the previous couple of examples. So we call that an amphiprotic species. So it can be acidic or alkalinic, which is just basey, and it's dependent on what it's paired with. So when water is paired with a base, it acts like the acid. And when water is paired with an acid, it acts like the base. So just know these things, especially this acid donates a proton and base does accept a proton. That's the key part of this entire piece.